Hi GeoData people. We're going to continue working with triangles. We are in Unit 2 in our new book, and we are in Investigation 2, and today we're going to do Lessons 3 and 4. So we're starting on page 91 in the printed workbook, and on page 91 in the book, you will note up at the top of the page that it says Investigation 2, Lesson 3. All right. So, in Investigation 2, Lesson 3, we're talking about midpoints and mid-segments. And so we're going to start with a triangle here. Okay, triangle ABC. Now, I'm not going to use a compass and a straight edge. Maybe some other time I can post a video for you to see that. But what we're trying to find is the midpoints of the sides of the triangle, and I've already determined that that is the midpoint of side AB, and this is the midpoint of side AC. That means it cuts the side exactly in half, 2 equal parts. And if I connect those together, that's called the mid-segment. So the mid-segment of the triangle, we're going to call that XY, the mid-segment cuts the sides in half. It goes from the midpoint of one side to the midpoint of another side. So that line segment is called the mid-segment. Okay? And there's some cool things that we can discover about mid-segments of triangles. And I'll show you a few of these cool things. Okay? When you compare, we know that this is half. AX is half of AB, right? We know AX and XB are the same length, okay? Same thing with this side and this side, okay? The cool also thing is that this angle here, AXY, is congruent to angle ABC. And this angle on this side is congruent to this angle, okay? So it forms congruent angles. Okay. And the other very cool and useful thing is that this line segment XY is parallel to this line segment BC. Okay, so line segment XY is parallel to line segment BC. Okay. And this would not be the only mid-segment. We could also make mid-segments for other pairs. We could have taken the midpoint of that side and the midpoint of BC and drawn a set mid-segment that way, which would be parallel to AC, right? Or the other way. So there's going to be 3 different mid-segments. You can create mid-segments for the other pairs of sides. All right, so we're going to go on now to page 93 in your book. And we're going to talk about mid-segments and medians. All right, so let's think about some of this that we've already talked about. So here we have in problem number 1, we have a mid-segment. So X is the mid-segment of this triangle ABC, okay? Because it says so, all right? It says so right there. Okay, so we're going to keep talking about that. So what if they told us that this piece right here, if we think of that as XY, if they told us that this length here was 9, and they told us that this length here was 10, we know that this piece here is also 9, and this piece here is also 10, and you know what else is very cool? It always cuts things in half. This side X is going to be exactly half the length of BC. So if BC is 30, that length is going to be 15, right? And this is going to be 9, and this is going to be 10. And the perimeter of ABC is going to be 9 and 9, and 10 and 10, 130, which is altogether 68. Okay. Now, here's another triangle, DEF. See, they drew the midsegment this way. This is the midpoint of DF. This is the midpoint of EF. There's another midsegment. So the cool thing is, remember I said when you do the midsegment, it creates congruent angles. So angle X is going to be 50 degrees, just like that one. Angle Y is going to be the same as this, but we don't know what that is. But do you remember we've talked before about the triangle sum, right? What do you know about the three angles of a triangle? This big triangle DEF has an angle of 50, an angle of 60, and a missing angle. Well, you know that 50 plus 60 plus y has to add up to 180, which means that y has to equal 70 degrees. Okay. All right. Let's move on to page 94. So on page 94, we have a triangle RST. Here are the midpoints of the sides. So we can draw midsegments. So watch this. What if we draw all the midsegments? So we're going to connect X and Y and Z, and X and Z. So we've now created 4 different triangles here, 4 small triangles. Well, remember, this side is the same as this side. This side is the same as this side. Remember all the congruences, right? And this one, ZT, is the same length as SZ. Okay. Well, remember we also know about things like angle, side, angle, and side, 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 and things like that, right? So we also know that this angle is the same as this angle, and this angle is the same as this angle, okay? And what ends up happening is that all 4 of those triangles are congruent. And you can prove it a number of ways. You can prove it using all the different side, angle, side, angle, side, angle, side, 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 all those different things. All 4 small triangles are congruent. Okay? And remember, this is going to be half of the length of ST, right? Okay. And so the correspondence among the 4 triangles is basically going to be that triangle RXY is congruent to triangle XSZ is congruent to triangle YZT is congruent to triangle ZYX. The only difference is ZYX is upside down. If you flipped ZYX over and then flipped it over again, it's kind of, or rotated it, it would match exactly, right? Take that one and you can either flip, or spin it, and you'll see that it lines up exactly with those other triangles. Okay, so if we wanted to state a correspondence, we would do this. Triangle RST, which is the big one. Now we can't say it's congruent because it's way bigger than the other small triangles, but this is what we can say. We can do this, just the wave without the equal bar. We can say that it is, and that's called similar. Okay, we're going to do a lot more with that, I think, in investigation 4. Okay, but triangle RST, the big one, is similar to triangle RXY. And what happens then is that all the sides of triangle RST are exactly 2 times the length of the sides of the smaller triangle. Okay, so the sides are all twice the length, but so you can read that. The sides of RST are exactly 2 times the length of the sides, but all the angles are congruent, right? The angles don't change. Okay? So that's a very interesting thing about similarity. All right, so let's go on to page 95 in your book. And now, instead of mid-segments, we're going to talk about medians. Okay, so medians are a little bit different. Medians take those midpoints of the sides, but instead of connecting them to other midpoints, we're going to connect them to the angle, the point on the other side of the triangle. Okay, so what we have here is we have triangle ABC. D is the midpoint of AB. E is the midpoint of BC. F is the midpoint of AC. But we're going to take each one of those midpoints and we're going to connect it back to the vertex on the opposite side. Okay, and these are called medians. Okay, they're the same midpoints that we used before, but now we're connecting them to the vertices. And look at, they all meet, they all intersect at one point, okay? And that point is called the centroid, okay? That point where they all meet is called the centroid, okay? And there's a really interesting relationship that happens here. When you do this, every single time, the distance from the vertex to the centroid is twice as long as from the centroid to the midpoint. AG is twice as long as GE. BG is twice as long as GF. CG is twice as long as CD, every single time. So your notes at the bottom of the page, point G is the centroid, and all the medians intersect there, okay? Points D and E and F are the midpoints, and segments AE, CD, and BF are called the medians, okay? All right, so on to page 96, the next page. So we can solve some little problems here. So here's our triangle ABC, and we have our medians drawn, and we know all the medians meet at centroid F in the middle. And we know a few things. We know DF is 4. We know BF is 16. So BF, that big long one there, is 16. And we know AG, so that's A to G. That's the whole big long one. Okay, so that all together we know is 30. And we can figure out all these other points now. So FC, how long is FC? Well, this is a median, and we know that this length here is twice this. So if this piece is 4, FC must be 8, right? 2 times 4. What about DC? How long is the whole median going to be? Well, it's going to be 12. It would just be the 4 plus the 8. What about AF? So we know AG, the whole thing is 30. We know this piece is twice as long as this piece, so you've really got like 3 parts. 1 part, 2 parts, 3 parts, right? So AF is going to be 20, and GF is going to be 10, right? So that's going to be a 20 and a 10, because that adds up to 30. BE, the whole big long length. Well, if this piece is 16, then this piece is 8, and then the whole thing is going to be 24. 16 plus 8. And EF, we know that's 8. We already figured that out, okay? Which was half of the 16. All right, so those relationships always hold true. Okay, now, I want to show you, going on to lesson 4 now, we are going to explore some relationships between the sides and the angles of triangles. Okay, so you've got on page 103, okay, this is lesson 4 now, going all the way on to page 103, you have triangle ABC, and we're going to look at the measurements of the sides and the angles here. Okay, so I've already measured these with a ruler, and I'll just tell you what the numbers are. This side is 10.4. That's the longest side here, side A. Side B is this side here, and it's 8.5. And this side over here is 5.5. I also measured the angles with a protractor, and it turns out this angle A up here is 93 degrees. Angle B is 55 degrees. And angle C over here is 32 degrees. They all add up to 180 as they should. Okay, and here's an interesting thing. The largest angle is 93 degrees. The largest side is 10.4. Notice this side is opposite from that angle. The longest side is opposite from the largest angle. Okay, and the smallest side is C. It's only 5.5, and you'll notice that it's opposite the smallest angle, which was only 32 degrees. Okay. Okay. And I can tell you that if you look on the next pages, there are other triangles there. I've already filled in the numbers for you, but again, you can see that the largest angle is opposite from the largest side. The smallest angle is opposite from the smallest side. And if you look at page 105, once again, the very small angle 17 is across from the very small side 5.0 centimeters. The large, huge angle 120 degrees is opposite of the longest side of 14.6. So that happens every single time. It's no big surprise. Okay, so here are some notes for you. Okay, so the first one on page 106. And you can pause to copy these down in your notes. Okay, the longest side is always opposite the largest angle, and the smallest side is always opposite the smallest angle. That's what we just saw in those measurements. Okay. What about the lengths of the three sides? So this is another important rule about triangles. The length of one side is always less than the sum of the other two sides added together. Okay? And these are actually theorems. The greater angle of any triangle is always opposite the longer side. That's the angle opposite the longer side theorem. And then we have the longer side of a triangle is always opposite the greater angle, which is called the side opposite greater angle theorem. And the last one is the length of a side of a triangle is always less than the sum of the lengths of the other two sides, and that is called the triangle inequality theorem. All right, so what we can do with these is solve some problems. We're going to talk about one more quick thing, and that's called exterior angles. So an exterior angle is if you have any kind of a polygon and you extend one of the sides outside of the polygon, and it creates an angle outside. That's called an exterior angle. Okay? That's called an exterior angle. And let's remember that linear pairs are supplementary. If there's two angles that add up to a straight, they add up to 180 degrees. Okay? So if we have a triangle here, that's our exterior angle out there. Okay? And remember, it has to add up to 180 degrees, and since this is 100, that one would have to be 80 degrees. Okay, so that has to be 80 degrees. Well, look at these two angles over here, 30 and 50, add up to 180, add up to 80 degrees. Okay, these are called non-adjacent, or often called remote interior angles. They're inside the triangle, but they are remote to that exterior angle. They're on the other side. They're not right next to it. Okay, so look at a couple more examples. On page 108, here we go. Here's an exterior angle over here. Okay, if this angle is 82, what's the other angle going to have to be? Well, it's going to have to be 98 degrees because they make 180. Well, look at 65 and 33 add up to 98 degrees, right? And look at this one at the bottom of the page, 108. Here's another triangle extended out to form an exterior angle. Okay, well, this angle out here has to make 180 with 44. That's 136 degrees. 89 and 47 is 136 degrees. Okay, so that exterior angle theorem can be very convenient. That exterior angle always equals the sum of those remote interior angles. Okay, and there is the theorem. The measure of an exterior angle of a triangle is equal to the sum of its two remote interior angles. Okay, so I would like to look at one last problem right here at the bottom of the page. And let's put all of these theorems to the test, all right? Is this triangle possible, or do these numbers, is something got to be wrong with one of these numbers? Does this make sense, or can it not possibly happen? So let's think about some possibilities. Do the three angles add up to 180? Do the angles add to 180? Well, we have a 48 and a 51 and an 81, and they do add up to 180. Whoops, 51, 51, 48, and 81, and they do add up to 180 degrees, so that's cool. What about the next one? Is each side length less than the sum of the other two? Well, let's just think about it. Is 6.8 less than these two added together? Yes, they would be well over 10, right? Is this one less than adding those two? Sure. Is this one less than adding those two? Sure. So is each side length less than the sum of the other two? Yep. It worked for all three sides. What else have we learned in these lessons? We also know that the longest side has to be opposite the largest angle. Is that true? Where's the longest side? Longest side is 6.8. Is that opposite the largest angle, 81? Yes. And is the smallest side, 5.12, opposite the smallest angle? Yes, it is. Oops, wait a minute. 5.12. Hang on, it almost faked me out. Where's the smallest angle? 48 is the smallest angle. Is 512 opposite of it? No. So it fails. It's impossible. This triangle cannot happen. One of the numbers is messed up. Okay? So that's it. That was a lot of little triangle theorems that we learned all in one set of lessons. So you can go practice applying these in your problem set.